In this video, we are going to learn about a very important component in system design, which is load balancer and its algorithms. So when you look at system design videos, and when we discussed about single point of failure, you might have seen this box where we write load balancer. What does it do? It takes a request from the clients and redirects towards an appropriate instance of the service. So let's understand it in much depth. Let's say we have multiple clients. We have n number of clients, and we have multiple servers of the same application. We have server 1, server 2, and server 3. Both are the servers of the same service. Now, without load balancer, we are getting a request, and the requests are distributing unevenly. Now, suppose we just have seen around 5 users here. Let's say we have n number of users, and this kind of uneven distribution may cause the server overload. How? Let's say this server is only able to handle load of 2 users, and we are trying to get 3. However, we already have availability of at least two connections for the server 2 and server 3. Now, what will happen? This server will crash. Now, to mitigate this problem, to solve this problem, we will bring load balancer in between. Now what will happen? The load balancer will receive the request from the users, and they will be distributed among multiple servers based on the load. So in simple terms, load balancer helps to reduce and prevent the load of server via redirecting the request to the appropriate server. So it is a component that distributes the request from clients in such a manner that only one single server does not get all the requests and gets overloaded. So now you may ask that how does this load balancer divides the request among multiple servers? So for that, there are multiple algorithms for load balancers and type of load balancers available for the job. So now let's look at the types of load balancers. So there are two types of load balancers. First is network load balancer, or they are also known as L4 balancers. Second is application load balancer. They are also known as L7 load balancers. Now we will look into each one of those type in detail as well. Now just for basic information, the network load balancer is faster, and each type of load balancer can access certain kind of data and they operate based on that. So for network load balancer, they generally have the information about ports such as TCP, UDP ports, IP address of source and destination. And based on this information, it can take decisions. And what kind of decision does a load balancer takes? So L4 load balancer usually takes the information such as TCP, UDP ports, IP address of the source, and then they route based on this information. Now L7 load balancers are more advanced load balancers, and what kind of information access they have, and they operate based on that. So it can read headers, sessions, event data, and cookies as well as response. And based on this all information, it can take decisions for routing. Since it's advanced, so it also have caching capabilities. And why does it have caching capabilities? It's because it can read the response as well. So based on my understanding, so based on the places I learned about load balancers, most of the algorithms that we see on the internet are for L4 load balancers. So the network load balancers or L4 load balancers are further divided into two types, and these differentiation is basically based on their algos. So network load balancer have two type of kind of load balancing. First is static, and second is dynamic. So under static algos, we have three algos. First is round robin. You might already know about that. Another one is weighted round robin, and third one is IP hash. Under dynamic algorithms, there are three in this as well: least connection, weighted least connection, and last is least response time. Okay, now let's look at these algos one by one. So what is a static load balancing? So as name suggests, the rerouting of the request are static in nature, which means they are fixed. Like it is pre-decided by a very simple algo, a very simple calculation, which request should go where. Let's look at the round robin load balancing. So we have this load balancer. So we have multiple clients over here, and we are getting the request which is being taken care by load balancer first. Now in round robin, we know that it's one by one. So let's say if we have two servers, so that it's pretty simple, right? We have only round robin, which means the request will be divided one by one. So let's say this is the request 1, 3, and this is, since it's round robin, so this server will get first request, this will to get second one, then this will get third one, back and forth. So this is it. So requests will be distributed in round robin format. And there are some advantages and disadvantages. Advantages is it is very simple and easy to implement, equal load distribution on the connected servers. Now disadvantages are all the servers are treated as equal. For some reason, if the server second, the instance second of this application is larger and server first is smaller, even then the load will be equally distributed. Due to which, if let's say S1 is, since it's smaller and we have multiple requests, so it may go down because of the load. And second will not get enough load, means the resources won't be used optimally. Now next comes the weighted round robin. So this is another static algorithm for load balance. Now it's since it's a weighted round robin, it means we put a weight on a specific server that will get request more often than the second server. Means we are adding a capacity, let's say we are adding a weight to a specific server, we are adding a preference to the server. Same example. Now instead of all these requests getting in a very round robin format, we are adding a weight, let's say, to this server. Now what does it mean? It means, let's say this is the capacity of this server, then server 2, which means a server 1 can handle 3 times of the request of server second. So in our scenario, load balancer will check that is the capacity of the server 1 available. It will check both. It will say, okay, it has 0 requests, it has 0 requests currently getting served. So preference is 3x. So it will send 1 here. Now still this is 0. Then second time it will see it's 0, it's still 1, but since it's more capacity, it will get second request as well. Now when the request 3 comes, it will check 1 into 0. It will check it, say okay, there is no request yet, and it will see 3x, which is 3 into 1. Then it will see okay, it can handle 3 requests still. So again it will get the third request as well. Now when it comes to the fourth request, it will see that okay, does it capacity is full? It will say yes, it is currently serving the 3 requests and server 2 is serving 0. Now at this it will get preference to the second server. Similarly, when the fifth request comes, it will check which server has the less capacity right now. It will see okay, if like it has 3 already, it's been serving, and it is only serving 1, so it may redirect fifth to this one. Now it will check okay, this server is serving 2 requests, it is serving 3 requests, but its weight is 3 times, means the capacity is more, and meanwhile there is a possibility that this first request might be completed, so the sixth will be allocated to this server, and back and so forth. It will keep on happening like that. So the weighted round robin tries to solve the problem of round robin algo by giving weights to the server. And weight may represent the size of the server or the capacity of the server based on what we have decided. Now the advantages are pretty clear, that low capacity server will get saved from receiving the large amount of requests, and this is also easy to implement because still the weights are static in this. So load balancer doesn't have to compute heavily on this one. Now look at the disadvantages of this algorithm. Now the interesting disadvantage is, for example, we have few number of requests and they are getting divided based on the weight. But let's say out of this, the fourth request and the fifth request is a long processing request, which means they are heavy or they need more processing power. But with our weighted round robin, we are just looking at the size of the number of requests which is being served by each server. So there is a possibility that all the fast processing requests are getting served by the large server, whereas long processes are being served by the server second, and due to which our lower capacity server may still get overburdened and may crash. So this is the disadvantage. Now next algorithm here in static one is IP hash. So in this algorithm, what happen is all the IP addresses of the clients are hashed, because all the clients will be getting sending a request with some system, right? and they will have unique IP addresses at that point. What will happen in load balancer? The IP address hash will be calculated, and a server will be assigned to specific IP address hashes. So in load balancer, we have IP hash, let's say allocation provided already in the configuration. Now, what does it mean? Let's say first user and fourth user will be always served by server one, and second and third user will be always served by server two. That's it. That's it all on IP hash. What are the advantages? So this is good when same clients need to connect with the same server. What does it mean? It means, let's say this server is nearby for client first and fourth, so it serves them fastly than server second, and server second may be close to the user second and third, or maybe second and third client always do the long running processes. So the server second is larger, so we are assigning according to that, and it is very easy to implement because it's static. Now there is a disadvantage of it. So in just there is also one component in networking which is proxy that also stay between load balancer and the client. So these proxies are generally present in almost every web application for security purpose. This is to hide the location of load balancer. This type of proxy right now that we are talking about is called forward proxy because it is forwarding the client request to the load balancer, and then load balancer is getting connected with the server. So these kind of proxies are called forward proxy, and generally this is secure for both user and the load balancer because user's IP address is never exposed on the internet, and load balancer's IP is also not exposed openly on the internet, like it's not traveling over the internet. And usually in proxies they have their own fixed IPs because it is also a server, so it will contain one IP, so whenever one IP address, right? So whenever client is giving sending the request, proxy gets in between, reads the request, redirects it to the load balancer, so load balancer will always receive the request from the same IP address. Now, in IP hash algorithm, since we are doing a hash of the client, and but in our case, the IP will always remain same because it's coming from the same proxy every single time. So there will be no guarantee that distribution will happen, and we are able to assign the appropriate server to the client because we never know the IP of the client in this matter. So this is a disadvantage for this one. So that's it for the static one. Let's move towards the dynamic load balancing. Now we have seen quite a lot of disadvantages on the static one because there is a possibility that server's IPs also changes, right? Client IP may also change because let's say we have proxy, but for some reason proxy usually doesn't remain same all the time. If you are using a cloud system, let's say AWS, GCP or whatever, so there is a possibility of constant changing of the IP addresses of the proxies or even the servers or even the load balancer. So the static somehow will not work in case of IP hashing if we are using. Or if we are using round robin, then we know the problem of the equal distribution based on size. For weighted also we have a problem with the longer processing. So then to solve all the issues, we try to fix it via dynamic load balancer, where the load balancer is more smart and advanced to manage the requests of the users to the appropriate servers. So now let's start with the very first algorithm, that is least connection. Okay, so what is least connection algorithm in dynamic load balance? So let's say we have again four clients and we are sending the request. Load balancing is in between to decide how to divide the load among the instances of the application. Now let's say this is server one and there are already three requests that are being served by the server one, and there are five requests being served by the server two. Means active connection, right? Like they are they are in progress. They are not done, they are in progress. Like it's active right now. It's active connection. So what load balancer will do, load balancer will check with server, so it will keep a track of the active connections with each of the servers it has, and will see whichever server has the least active connections, it will redirect that request to that specific server. So in our case, the server 1 has the least active connection, which is 3, then 5. So the client first request will go here. Same will happen for client 2. Now it has equal active connection. Now in case of third and fourth, it may allocate any one of the server. It may, let's say, fall back to round robin in that case because both server have equal connections, or it may use weighted one. So it's generally good to have a fallback mechanism as well because it's dynamic. So you can configure how you like it. But with the leads connection, the connection count is the main purpose over here. Okay, so it will check the active connection. Now, advantages are pretty clear about this. It makes sure that none of the servers get overburdened based on active connections it has and the capacity. Yeah, we are basically assuming that both servers in this scenario has equal capacity. Now, disadvantage. So, in network protocols, we saw that there are TCP connections which remains open even if they are not actively sharing something. So there's a possibility that any one of the server may have that TCP connection active, but there is no traffic. It's just open. It's just a path that is connected with the client, but it's not transferring anything. But the load balancer will count that as active connection and it may confuse it, due to which it may redirect that request to another server and may cause overburden. And there is no difference between low and high capacity servers. So if we keep that TCP connections in the picture, so there is a chance of overburdening. Now, next one is weighted least connection. Now, in this one, we have already discussed slightly in the above one. So we are gonna add the weight to a server, and the weight can be based on the capacity of the server or the priority we want to put a server to request to receive more requests. So how load balancer will decide? Now, load balancer will calculate the ratio of number of active connections based on its weight. Based on it, server with minimum ratio will get the request. So in our example, we saw, let's say this server is currently have 2 requests and it is serving 3 requests already. So now the client one is requesting something. So ratio will be calculated, which would be 3 by 10. That would be 0.3, and its ratio would be 2 by 1, which will be again 2. So this has the least active weight, the least connection, sorry, the least ratio. So C1 will be served by this one. Then C2, it will check 4 by 10. It would be zero point 0.4. Then again C2 will be gone here. Then again C3, 5 by 10, zero point 0.5. Again C3 will be here. Then 6 by 10, 0.6, C4 will be there. Similarly, until the ratio is not greater than or equal to 2, this server will keep on accepting the request by the load balancer. So what are the advantages? So unlike the previous one, in this one, capacity and active connection both will be taken into the consideration. So low capacity server will have low chance to get overburdened over here. So it will not crash. And this is dynamic in nature. So if the number of requests active connection drops, so the ratio will be calculated accordingly. Now the disadvantage of this is the TCP connection part may still confuse the load balancer because we are not taking that into the consideration. And if the high capacity server is far away from the requested client location, then the latency will be increased for that specific user. So maybe it might be better to route that request to the low capacity one if it's nearby, because it will be able to respond faster and the trade-off won't be a problem in that. Now the last one is least response time algorithm in dynamic load balancing. So for this example, we are taking one more server. Now in least response time, as there is one more parameter that is taken into consideration, that is called time to first byte. So what is this time to first byte? The interval between sending a request and receiving the response from the server. Okay, means the first packet from the server from the response is taken into the consideration for specific user. So there are basically two parameters that is taken into consideration. First is this one, time to first byte, and another one is the active connection. So it resolves the problem of the previous algorithm that doesn't take into the consideration about the latency. So how load balancer will decide? So whenever a request comes to load balancer, what it will do? It will pick the server which have the less active connections and time to first byte. It will do a multiplication for that. If let's say multiple server give the same response, in that scenario, fallback will be round robin for that specific user and for those servers who have equal value for this calculation. Okay. For example, this server active connections are 2 and time to first byte. And for this server, we have active connections as 4 and time to first byte is 1. And for this one, we have active connections as 0 and the time to first byte is second. And this is calculated dynamically for each request, by the way, or you can say by each location. It depends how optimized we make this algorithm. Maybe not for user, maybe just for region. Let's say some user are getting requests, sending requests from US, so it becomes US region, American region, Indian region, and accordingly, the load balancer calculates the time to first byte and the active connection for the servers available for those. So here, let's say we have client three, we have let's say client two, request is coming, and it checks, and for server one, it says okay, it's 3 into 2, which is 6. For S2, we are getting 4 into 1, which is again 4. And for S3, let's say we are getting 2 into 0, which is again 0. So server 3 will receive this second client request, which is here. Now what happens? Active connections become. Now client third request come. Then again this calculation will happen. For server 1, we still have the same 6. For server 2, we still have same 4. Now for server 1, we have one active connection. It will become 2. But for client 3, since it's less than all the both above, then this will be also served by server 3 for this specific client. Now what is happening? Server 2 and server 3 is clashing. What was the fallback algo to use? Which is round robin. So load balancer, we check what was the last server it served. So it will say, okay, server 3 was used last time. Now we will go give this request to server second. So the client 4 will be served by this server. Okay. So that's all. I hope you understand what is load balancer and what does it do, and you know all the algorithms and will be able to choose better. So tell me in the comments what algorithm was more efficient and why. If you have any questions, feel free to comment down. Thank you. See you in the next one.